3.3, number 142, is the second problem of great import. For derivatives. Okay, it is to find where the slope of the tangent line to a curve, which is of course the slope of the curve itself, takes on a particular value. And usually, but not always, that value is 0. Okay? As it is in the first part of this problem. So here we have f of x equals x cubed plus x squared minus x minus 1. I want to find, they said, where tangent line is horizontal. So what would that mean? i.e., slope, right? For a tangent line to be horizontal, the slope of the tangent line, the slope of the curve, must be a value of 0. Okay? Every horizontal line has a 0 slope. So we simply need to take the derivative and set equal to 0 and solve. So f prime of x is the derivative applied to the totality of the function. And then, because the most outer operation happening is these sums and differences, the derivative will distribute across to each term in and of itself. And the first three are power rules, and the last one is the constant rule. So this goes to 0, and the other ones become 3x squared plus 2x minus 1. So there's our slope for this function anywhere on the curve. And now we just want to find out what x values will make this slope 0. Okay, so there again, there is f prime equal to 0, slope of tangent line, slope of curve equal to 0, implying a horizontal tangent there. Now we just solve in the usual way. 3 times negative 1, right? Take the first coefficient times the last, and we get negative 3. And we find the factors of negative 3 to be 1, negative 3, and a negative 1, 3. And it looks like, all right, there's our pair that adds up to the middle coefficient of 2. So therefore, we will split the middle coefficient into these two and attempt to factor by grouping. So we have 3x squared plus 3x minus 1x minus 1 equal to 0. And now we'll group them. And then we have 3x in common between these two terms. So we're left with x plus 1. We have negative 1 in common with these two terms. We're left also with x plus 1, which is the q we're looking for. To factor off the x plus 1 from each of the remaining two terms, we now have x plus 1 times the 3x minus 1 residual equaling 0. All right, that immediately implies that either x plus 1 is 0 or 3x minus 1 is 0. So we have solutions x equals negative 1 or x equals a third. All right, so we have the the locations along the x-axis, -1 and 1/3, where the derivative becomes 0, which means the tangent line there will be horizontal. Okay? Now we just plug these numbers back into the original function to get the full coordinates for these points. So it's -1 comma f of -1 is one location, and we have 1/3 comma f of 1/3 as the second location. When you plug in -1 to the original function, it's pretty obvious you're going to get 0 just upon inspection. So this is down here, -1 comma 0. Okay? There is one solution. There's one point where the tangent goes horizontal. F of 1/3 is not quite as obvious. So f of 1/3 should be a 27th. Write this very quickly. A 27th plus a 9th minus a 3rd minus 1. If we give everything a denominator of 27, we should arrive at something like a 27th plus 3 27ths minus 9 27ths minus 27 27ths. Okay. And let's see. -27, -9 is what? -36 plus 4, -32 sounds about right. So -32 27ths is irreducible. So our second coordinate pair, where the tangent line takes on a value of, the tangent slope takes on a value of 0, is 1/3 comma -32 27ths. Okay.